In this video, we're going to take a look at long division of polynomials. Long division you've seen in the past, probably did this back in first, second, third grade a long time ago. You did it with numbers, and the process is going to be exactly the same. So we're just going to jump right into it. Let's divide, and we'll take the polynomial x squared minus x minus 6. I'm going to divide that by x minus 3. So first thing to perform long division, we're going to set up our division. So x minus 3 is our divisor, and we're dividing into the x squared minus x minus 6. So what we're dividing into, that goes inside the division house, and what we're dividing by, that goes on the outside. And so then we ask ourselves the question, what is x squared divided by x? Or another way of asking that is, what times x gives us x squared? And the answer to that is just x. X times x will give us x squared. I think it's easier to leave everything lined up. And so because when we divide, we get x, I'm going to line that up in my x column right here. So now that I've figured out what I get when I divide, I'm going to actually multiply these two things together. X times x minus 3, and really I should keep that in parentheses. X times x is x squared, and then x times negative 3 is negative 3x. For my next step, I need to subtract these two lines. Keep in mind, we need to subtract every single term. And so one thing you may have been taught by a previous teacher, which is fine, is to actually just go ahead and switch all the signs. Right? It's the same thing as subtracting. You can do that as well. But I like to just leave the subtraction out front, so I'll have x squared minus x squared. They cancel, as we would hope. But if they did not cancel, that would mean we had done something wrong. And then we have negative x minus the negative 3x. Well, double negative turns into a plus. Negative x plus 3x is 2x. Now, we weren't subtracting anything right here, so we would just bring that negative 6 right down. We're essentially subtracting 0 from negative 6, which just gives us the negative 6. We're going to restart the process. What times x gives me 2x, or another way of saying that is 2x divided by x is what? And that should be a positive 2, so I'm going to write a plus 2 lined up with the constants. And now I'm going to multiply. 2 times x is 2x, and then 2 times negative 3 is a negative 6. Just like before, I'm going to subtract to get to the next line. The 2x is canceled, the 6 is canceled, I'm left with the 0. And so our answer when we divide these two things is the x plus 2. Now this one we could have actually done without long division. If I'd set this division problem up a different way, x squared minus x minus 6 divided by x minus 3, remember fractions are just division, we would have looked at this and said, oh, we can factor the numerator, x plus 2, x minus 3. And then in the denominator we would have had the x minus 3. This is x minus 3 is canceled, leaving us the x plus 2. And so this one, because it factored, and because the factors were the same, was a relatively simple problem to do before. But where this long division is going to help us, it's going to help us when we go to divide any polynomial. So something that doesn't factor, or something that the factors don't cancel. Even if something factors, the factors might not cancel. So let's take another example. Let's say we have x squared plus 7x plus 6 divided by x plus 4. This is an example of something where this does factor, x plus 6, x plus 1, but those factors won't cancel. And so we need to use long division. So I'm going to set up my division. X plus 4, we're dividing into the x squared plus 7x plus 6. What times x gives me x squared? Well, an x. Then I multiply. X times x plus 4 is going to give me x squared plus 4x. I'm going to subtract to get to the next line. The x squareds cancel. 7 minus 4 is 3. The 6 comes straight down. What times x gives me 3x? That's a 3. 3 times x is 3x. 3 times 4 is 12. Let's subtract my way down. The 3x is canceled. 6 minus 12 is a negative 6. X does not go into negative 6. There's nothing I can multiply x by to get to negative 6 that isn't some sort of a fraction. And so this negative 6 is what we call the remainder. Probably remember that from like I said, a long time ago, back in the first time you did this long division. And so with this remainder, there's a few options back in the day when we were just doing long division with numbers. We could have carried on by putting a 0.0 and just expand it out with the decimal point. Well, we can't have decimals with polynomials. Polynomials, we don't have a decimal form of a polynomial. Also, sometimes just left as a remainder of -6, and that was fine. That was very basic though. Or the third option was to write it as a fraction, and that's exactly what we're going to do. We're going to write a -6 over x plus 4. And so that's our answer. When we divide these two things, we get x plus 3 minus 6 over x plus 4. And let me just go back to that fraction for a second. Where is that coming from? Well, it's simply the remainder over what we're trying to divide by. We're dividing by the x plus 4. We couldn't divide x plus 4 into the -6 anymore, so we write it as our fraction. Now, an alternative to this is we could have written a plus a -6 over x plus 4. That would have also been fine. It's just that to bring that negative forward is a little bit more concise. And so there's our process of long division. We can do long division with linear divisors. So notice the x plus 4 is linear. It's just an x. We can also do it with non-linear divisors as well. So let's take, I'm not just going to set this up in the division house for interest of time. X to the 4th minus 5x squared. Sorry, let me do a cube for right now. Plus 2x squared plus 3x minus 1. I'm going to divide that by x squared plus 1. Alright, so the first thing I'm going to do is the same step as I've been doing. X to the 4th divided by x squared is what? It is x squared. Now I'm going to multiply. Notice how I'm keeping things lined up. That is not mandatory, but I think it does make your life a lot easier. So x squared times x squared is x to the 4th. X squared times 1 is x squared. And now I'm going to subtract these two lines. I said x to the 4th and I wrote x squared. That should be an x to the 4th because they should cancel. Negative 5x cubed minus nothing is negative 5x cubed. Notice there's nothing underneath of that 5x cubed right here. Then we have a 2x squared minus an x squared. That's going to give us an x squared. We're going to have a 3x minus nothing and a negative 1 minus nothing, so these are going to come straight down. Next, restart the process. Negative 5x cubed divided by x squared is how much? It's a negative 5x. Negative 5x times x to the 5th. I have no idea where I got that from. Try that again. Negative 5x times x squared is negative 5x to the 3rd. Negative 5x times 1 is a negative 5x. And I'm going to subtract these two lines. X cubes cancel. X squared comes straight down. A 3 minus a negative 5 turns into a plus 5. That gives me an 8x minus 1. X squared divided by x squared, that's just going to give me a 1. And so we'll have x squared plus 1. Subtract those two things. The 8x comes straight down. Negative 1 minus 1 is a negative 2. X squared does not go into 8x, and so at this point, that is my remainder. So I'd write that remainder as a plus 8x minus 2 over the x squared plus 1, what we were dividing by. As here we have actually a linear component to that numerator. That remainder was linear, and that's fine because we could not divide that quadratic into it any further. So we were done there. That's as far as we can go. Let's take a look at one final problem. Let's take a 2x squared minus 3. I'm going to divide that into, I'm going to set it up as a fraction for starters. Let's take a 4x to the 3rd plus 2x minus 1. So I'm going to divide these two things. I don't know how to factor these, so I'm going to use my long division. The 2x squared minus 3, I'm going to divide into the other expression. The other expression, we have the 4x cubed. Notice there's no x squared term. Now this is not mandatory for long division, but remember I've said a few times now, it's much easier to keep things lined up. It's much easier to keep x's on top of x's, x squareds on top of x squareds. So for formatting reasons, I think it is much easier to put 0x squared in there. To put any factor, or rather any term that you're missing, any x to an exponent, anything that you're missing, put the 0x squared in there. It's going to make your life easier. It's going to keep the formatting better. It's just going to make everything a lot cleaner. Now after this video, my next video is going to talk about synthetic division. With synthetic division, that is absolutely mandatory. So again, just to get in the habit of doing it, I think it's a good idea to put those zeros in there when you don't have a certain term. So what times 2x squared gives me a 4x cubed? Well, that would be a 2x. 2x times 2x squared is a 4x cubed. 2x times a negative 3 is a negative 6x squared. Negative 6x, I have that in the wrong category. Sorry, let me try that again. That should be a negative 6x over here, not a squared. And now when I subtract, they cancel. We're left with 0x squared. 2x minus 6x, 2x minus a negative 6x turns into a plus 6x. That should be an 8x minus 1. So right away we're down to just the remainder. So we can write this as a 0x squared just goes away. The 8x plus 1, try that one more time, 8x minus 1 over 2x squared minus 3. And so there is our answer. In the next video, I'm going to be discussing synthetic division. Synthetic division is kind of like a shortcut on this. If we notice, every single time that we're doing long division, we're doing the exact same steps over and over again. We are taking the top, dividing it by the bottom. We're looking at what do I need to multiply this number by to get to this number. We do that. We do that multiplication, and then we subtract. Then we do the whole process over again. What number do I need to multiply this one by to get this next number? We just do that process over and over again. What number do I need to multiply? All right, let's multiply it. Let's subtract. What number do I need to multiply? Let's multiply. Let's subtract. And so synthetic division, because we're doing the same processes over and over again, kind of streamlines it a little bit for us. So we'll see that in the next video.